afternoon. Please join me in welcoming Martin Lau. Martin is a professor at Newcastle University in the UK, and he specializes in experimental and behavioral economics with focus on risk and uncertainty. And together with Glenn Harrison, who several of you know, he's good friend of John, they designed and evaluated several field experiments in Denmark, and the results are published in very prestigious places like the AER, the International Economic Review, Econometric, and so on. Today Martin's going to talk about discounting.
Okay, yeah, thank you. Yeah, so I'm going to talk about a new set of field experiments that we have conducted in Denmark. We call it field experiments, although it's basically just a lab design that we take out into the field, and then we do these experiments with non-standard subject pools, so non-students, and then we see how this behavior varies across different household groups. This work is with Steffen Andersen, and he is at the Copenhagen Business School, and then Glenn Harrison and his wife Lisa Rothström. So this is really just one of many papers with this team here. So I'm going to talk about two papers. I know that a rather long paper has been circulated. I'll talk partly about that one, and then I hope there's also time to talk about another one that's about the correlation aversion. The first one here, the one that has been distributed, is about hyperbolic discounting and whether discount rates are constant over time or not. So that's just focusing on the discount rate tasks that we did, where we also control for risk attitudes, and then we also had another task in those experiments where we look at the interaction between discount rates and risk attitudes. And I hope there's time also to talk briefly about the basic idea in that design. That paper is still under construction, or under construction. So is this paper. We are conducting some additional experiments that I'll be talking about as control features. So this is still work in progress. The discount function is well, it really specifies the weights that you place on outcomes that you receive at different points in time. So the further out the outcomes are, the less weight you place on those outcomes. And the discount rate is then the ratio between those weights you place at different points in time. And there are various specifications of these discounting functions, and the early ones were quite simple and very convenient to work with, and it specifies an exponential function. And the nice thing there is that the discount rate is constant over time, and that implies also that that we have time-consistent behavior. So if you make a plan now about some decisions in the future, then you'll stick to that plan and carry out those plans in the future. Now, the conventional wisdom now seems to be that people do not behave in this time-consistent manner, or at least that they do not have this exponential discounting function, but rather a hyperbolic function. And this hyperbolic function, it implies that the discount rates, they typically fall over time with the specifications that they use, and that can lead to time inconsistent behavior. And it's been used as an explanation for various types of behavior. So this could lead to undersaving, for instance. So you may have a long-term saving plan now, and then you systematically deviate from that plan later on. So you're not as patient once you are going to carry out the plan, and that can lead to undersaving in a sense. Another example that psychologists, they typically come up with is, or that has been used to explain behavior in that area of research, is addiction. So addictive behavior can also be represented, or at least explained partly by a time inconsistent or hyperbolically discounting story. I'm going to talk about three major families of functions. I mean, there are many functions out there for discounting. There's the classical one, the exponential one, and then I'm going to talk about two hyperbolic ones. There's the classical hyperbolic discounting function, and then there are some what we call quasi-hyperbolic discounting functions. Well, I should say that Well, there's the exponential one, then there's the hyperbolic discounting function, and then we have quasi-hyperbolic discounting functions. Within the hyperbolic ones, you see for some specifications that the exponential discounting function is nested in those specifications. So you can actually directly test whether they are hyperbolic or exponential. And then there are certain specifications where the exponential function is not nested. So you can't make a direct test of exponential versus hyperbolic discounting. And then there's this other part of the literature where you have quasi-hyperbolic discounting, and it's basically just an exponential discounting function, and then you add another parameter on top, which is basically just a risk premium to any delayed outcome. So it's really the most simple move away from exponential discounting. I'll come back to the specific formats of those. The nice thing about the quasi-hyperbolic one is that the exponential discounting function is also nested within that specification, so we can make a direct test of the exponential function versus the quasi-hyperbolic type of behavior. So I'm going to talk about those families of functions and how we set up experiments to test for hyperbolic versus non-hyperbolic behavior, and what we find in the Danish context. So this is the third field experiment that we have conducted in Denmark. The first one in '97, we only looked at the discount rates alone, and then we did this with a representative sample of the population, and the sample size was 253 subjects back then. The main focus there was simply just to look at how behavior varied across household groups. Then the next set of experiments was 6 years after, in 2003, and there we controlled for the nonlinearity of the utility function. So we move away from this assumption of risk neutrality, and then we take the curvature of the utility function into account when we estimate the discount rates. And that can have a dramatic effect on the level of estimated discount rates. So the average, if we assume risk neutrality, then the average discount rate is 25%, and that drops to 10% when we control for risk attitudes. In both of these sets of experiments, we have a delay to the early payment of 1 month. So people are presented with a choice between a sooner, smaller reward and a later, larger reward. And that sooner, smaller reward is always after 1 month. Yeah.
Can I interrupt you, so just to make sure that I understand properly? So the idea of risk comes into play that what I'm having now is for sure, whereas something that comes in the future might be risky?
No, it's really when you specify the intertemporal utility function. So what you do is, so if you have your intertemporal utility of some income now plus some income later on, then what you do is, instead of just looking at the monetary outcomes at these different points in time, you take the utility of these monetary outcomes. And this is really what you typically do in the intertemporal context. And then you need to control for the curvature of these instantaneous utility functions. And that can have a dramatic impact on the estimation of the discount rates. So if these are concave, the distance between this amount and this amount will be smaller, and the implied discount rate here will fall in the estimation. And it's not just a trivial amount or impact it has on the discount rate here. It's really a large one. So what we did was we had 2 tasks. I mean, in the very first experiment, we only had 1 task to elicit discount rates. So we only focused on eliciting the delta parameter here. In the second set of experiments, we had 2 tasks. One, the typical discount rate task, and the risk aversion task a la Holt and Laurie, where we estimated the curvature of these instantaneous utility functions, and then we did joint estimation. And now what we do in the next step, and which I hope that I have time to talk a little bit about, is we want to move a little bit further away from, and then specify a flexible functional form for the intertemporal utility function. And the specification we look at here is this specification. And the idea here is to see if you have this additively separable function here, what happens is that the intertemporal elasticity of substitution is equal to 1 over relative risk aversion. So there's this forced link between relative risk aversion and intertemporal elasticity of substitution. And if you have, for the instantaneous function here, if you have constant relative risk aversion, like this, then this will just be 1 over R.
What would the value of T be? Measured in weeks or months?
Well, we typically translate these discount rates into annual rates.
So money is received in a year or so?
Yeah, we vary the T. So in the first set, we varied T between 1 month and 3 years. Second time around, between 1 month and 2 years. And now, this time, we did it between 2 weeks and 1 year. See, most of the action, when they talk about hyperbolic behavior and hyperbolic discounting, and this fall in discount rates over time, that fall is most dramatic for the short time periods. That's where all the action takes place. Once you move beyond 3 months, then there's not much action anymore. It's really difficult to tell the difference between the exponential and the hyperbolic discounting function. So the big differences are for the short time horizons. So we chose this time to focus more on those time horizons that we've done in the past. So we did 2 things that really, what you can say, I wouldn't say we did all we could to find exponential discounting, but we wanted to stress test these assumptions about hyperbolic discounting. So we had 2 treatments that didn't really make it easy to detect hyperbolic discounting in a sense. I'm not exactly, I can perhaps choose my words a bit more carefully, but we had a delay to this early payment option of 1 month. So we had, and the idea was to make the transaction cost between the early option and the later option similar, right? So other people, they have this early option, this early payment option is typically immediate in many experiments, and then you can argue that there is a difference in transaction cost between the 2 payment options that will be directly influenced, or that will be directly reflected in the estimation of the discount rates. So we had this 1 month delay, but you can also say that that actually removes the possibility of some of the hyperbolic behavior. This passion, we remove the tendency for the passion for the present, basically. So they say hyperbolic behavior is a passion for the present. That's the story behind quasi-hyperbolic discounting, and that's why they attach a risk premium to any delayed outcome. And by having this delay to the early payment option of 1 month, we just remove that. So we are, with this treatment here, we're not able to test quasi-hyperbolic specifications. You need a treatment where you also have immediate payments.
The idea of the transaction cost that if you have immediate payment, just the experiment is right there, it's all wrapped up at this current time, but in the future, you're going to have to come back, send an envelope in, all this kind of stuff. Is that the idea?
Yes, that's the idea, yes. You can help, I mean, there are ways of trying to avoid this. So we transfer money to people's bank accounts, for instance, so they don't have to get back to us, or we just try to minimize the cost of actually getting the money, and we want to make that similar across the payment options. Now, the other treatment that is considered controversial by the hyperbolic guys that we had in our experiments is that we provided the implied interest rate information. So when we had a choice between 2 options, we also mentioned the implied interest rate if they took the later, larger option. Most people in the literature, they haven't done this. And the idea here is simply just to make the comparison between the early and the later option easier for people. And we also had some arguments about, well, this is required in the Danish context whenever you take up a loan or something like that, and then the bank has to provide this information and so on. But you could also argue that in many contexts, people wouldn't have access to this information. If they just make some daily decisions, for instance, then typically they wouldn't have this information. So we are also looking closer at this treatment here. So the idea now is to try to stress test the behavior we've seen in the past and then see if we actually find hyperbolic behavior now. We haven't found hyperbolic behavior in the past, or we have only seen a very small tendency for hyperbolic behavior, and most people have argued that, well, it's simply just due to these two treatments here, and now we want to stress test this. So we look at this, what we call the front-end delay. So no front-end delay, that means immediate payments. We have a treatment with that now, and no interest rate information. And the conclusion is that we still find no hyperbolic behavior. And then I'm going to talk a little bit about some options, or not options, but some explanations perhaps for why we don't really find this, or at least we want to. Well, one argument is that we are using non-standard subjects here, not students, so it could be an artifact of using students in experiments, for instance. So we've also conducted some experiments with students to see if we get this behavior or not, and we don't find that. We find a higher tendency for hyperbolic behavior for some specifications, but they're not really statistically significant in the tests.
The Danish hyperbolic guys must come up with some humorous jokes about people in Denmark being a certain persuasion.
Yeah, that could be.
So you come and do an experiment down here, I guess. You see two opposite sides of the planet. You know?
That would be nice. We've thought about doing experiments at various places in Sweden and then see if, because there's quite a significant difference in daylight, especially in the winter. Well, also in the summer, of course. But you have, up north you have the midnight sun, and in the summertime complete darkness in the wintertime, and it could be that behavior is different up there compared to the south, for instance. So we've been thinking a little bit about that. It'll probably never be done, but let's see. Anyway, we don't find any hyperbolic behavior. So these are just some of the alternative discounting models in the various directions it's taking. I'm going to focus on the exponential function, of course, just as the benchmark, then move over to quasi-hyperbolic. I'm sorry about it's difficult to see really. Then move over to quasi-hyperbolic discounting. I'm going to talk also a little bit about the Weibull function here. What is nice about these two functions is that the exponential function is nested within these functions. So this is a hyperbolic function, this is a quasi-hyperbolic function. We can directly test for the exponential function within those specifications. And then we have the traditional hyperbolic function up here where we can't do this direct test, or where the exponential function is not nested within that specification. This is really just the definition of discounting. So it's just the discount factor that makes you indifferent between the utility of some income at a later point in time and utility at an earlier stage. And then you can have different specifications for this discounting function. And the most popular one, or in the early literature, was this exponential discounting function here, and the implied discount rate is constant over time for this specification. Now, there are two different directions or different types of quasi-hyperbolic discounting functions. The early one that has been quite popular is, and it's really been used a lot, was first proposed by Phelps and Pollack back in the late 60s, I think, quite a long time ago, where it was taken up by Leibson in 1997. And the difference between the exponential function and the quasi-hyperbolic function is that you just replace 1 by this beta parameter up here. If beta is equal to 1, then you're back to the exponential function. If it's less than 1, then you have the implied discount rate, it falls over time, and then you have hyperbolic discounting. And it's been used quite a lot. There is a difference now. This rate here, you can view this as a risk premium to any delayed outcome. And the way it's specified here is it's a constant, but this constant is a ratio of the principal, right? You can also have a fixed cost specification where you simply just you can say, okay, I require $10 to any delayed or to delay any amount, for instance. This is not what this function here is doing. This is just some fraction of the principal. You can also have this other specification, and this was proposed by Bissin, Ben Habib, and Schotter, and they got it out in Games and Economic Behavior recently. And this specification can look something like this. The important part here is this term. This is just really, I mean, since the first working paper option, they basically just had the exponential part here, and then they added this fixed cost here. Now they have added also some parameters to reflect quasi-hyperbolic discounting and hyperbolic discounting and so on. So this beta parameter here reflects quasi-hyperbolic discounting. This is to reflect the theta one here to reflect some hyperbolic discounting. But if you can easily imagine just have the exponential part here, and then you add this fixed cost here. So just focus on this one here, and that says that you just require a certain amount to any delayed outcome. You can say that it's a bit surprising that it's taken a while, or such a long time really, to come up with this alternative specification to the one that was proposed by Leibson. But it is an interesting one, I think.
Can I just frame what I sort of see these two functional forms as happening is that we've got some principle out there in the future. Essentially, with the beta, you're saying, oh, I'm going to apply beta to that, shrink it down a little bit, then apply my discount.
Yes.
This one says, what I'll do is I'll take off some fixed costs and then apply my discount. Well,
Yes.
I'll apply my
Yes.
discount, whatever it is. One is a kind of a fixed idea,
So
but the whole imagination is that when I'm processing things in the future, I think, oh, it's out there in the future, not worth quite as much now. I don't know how much now, but I'm either going to take a percentage off or I'm going to take a fixed cost, and then I apply some.
yes. So the way to test for this specification here is to have treatments where you vary the delay to the early outcome. So either an immediate option or a delayed option to the early outcome. So these front-end delay treatments. So either we stick to the 1 month front-end delayed in one treatment, and then we have an immediate payment in another treatment. And the way to identify this one is by varying the principal. Because if you increase the principal, this part here should have less of an effect on discounting, right? So if the principal becomes large enough, then basically you should see exponential discounting. This one here should simply just become insignificant at some point, depending on how large that fixed cost is, of course. Okay, so we have two treatments: the front-end delay, no front-end delay, and then we also have a treatment where we vary the principal to test for this fixed cost specification. Then we have various hyperbolic discounting functions. This is the early one that has been used. I think that was proposed by Herrnstein, but you can use various ones. And they became more and more flexible in the specifications, and also harder and harder to estimate, basically. I mean, some of them are so flexible that it's really hard to get the stuff to converge. And then one that we like, and that has been proposed by one thing here is you cannot, the exponential function is not nested within any of these. So you can't test directly for exponential discounting with any of these functions. And then we have the Weibull specification here, and that has been used by Reed in 2001. And you have this exponential function here of r times t raised to 1 over s. If s is equal to 1, then you're back to the exponential function. And if s is different from 1, then you have hyperbolic discounting. So the exponential function is nested in this one. So you can say that this parameter s can be viewed as slowing down or speeding up of time as perceived by the individual. That's one interpretation of this parameter here. So we are going to test these quasi-hyperbolic specifications, the two different types, and this Weibull discounting function. Those are the ones that I'm going to focus on. I've already talked about the experiments that we've done. It's a coincidence that we have these 6-year time intervals here. It's down to when we got the funding. I should also say that the time horizons that we provide to subjects is also dependent on the time horizon of the project. So initially in the first one, this was money that we did these experiments when I worked at the Ministry of Business and Industry. The first one, we had a lot of flexibility in the time we had the money, so we had these time horizons up to 3 years. Here we had a 3-year project. It took a year until we got started with the experiments. The first year was really just getting the design in place, and then we worked with 2-year horizons, and now we've just reduced that to 1 year for the reasons I talked about earlier. We've seen some progress in the estimation techniques. So early on we just started out simple with interval regression models and so on, and then now we have moved into maximum likelihood estimation of these structural functional of these functional forms. We are not just eliciting one parameter anymore, so we have to move into these more advanced techniques. So we have 3 types of tasks in the designs. The first part is the first task is binary choices over lotteries, where all the outcomes are paid at the experimental session, at the end of the session. Then we have binary choices over time-dated outcomes. For the immediate payments, those payments were paid out at the end of the experiment. You also see some people pay it out the day after, or you can also make the transfer today and then they receive it later and so on. We paid it out immediately, and then later payments were done by bank transfers. We had the Fed, no Fed treatments, and then we had horizons that varied between 2 weeks and up to 12 months. So we have 13 time horizons in total. We picked 4 at random for the subjects, and they were each given 4 randomly picked time horizons. And then we had a treatment where the time horizons that were presented to subjects, it was either in ascending or in descending order. That can also have an influence. We don't find anything there, which we also expected really, but it was just really to test this. And then we have binary choices over time-dated lotteries, and that's a combination of the 2 types of tasks, and that is to look at this idea of correlation aversion and whether this assumption of additively separable intertemporal utility functions is a reasonable assumption, and that is a test of this, or this is the functional form that we use, and then we test whether this sigma parameter here is equal to 0 or if it's significantly different from 0. And that's the third task. We varied the order of these 2 parts of the experiment here. So some subjects did the risk part first, then the discount rate. Others did it in reverse order. and then we always had the third part here as the final task. And the reason is that this one is quite hard to explain to subjects. So it's we thought it would be good training to go through these two first, and then they would be it would be easier to comprehend this third part here. So we are able to test for order effects for these two, but not for the third one here. Decision tasks, we have, well, in the past we've used these Holden-Lowry types of tasks. We still use the, basically, well, it's really a combination between the Holden-Lowry design with a multiple price list and the Hay and Orm design, where they present the binary choices one at a time. We also present the binary choices one at a time, but there's a certain structure to the way we present these binary choices, and I'll come back to that. And then for the discount rate experiments, we use the design, the multiple price list from Collar and Williams, and that we have expanded later on. And then the new task is a combination of these two. We use this multiple price list idea, but present each row in the multiple price list one at a time. And I'll be more specific about how we present those tasks. So I'll come back to those tasks. The first one, this is the risk aversion task. I'm sorry, this is in Danish. It's easy to understand, so I'll just explain briefly. So this says here decision number 11 out of 40. So we gave the subjects 40 of these choice tasks in the risk aversion part. So this is number 11 out of 40. Then they had option A and option B. And this box here, it says that you will receive 2,000 kroner if the die shows 1, and 1,600 if the die shows 2 to 10. So there's a 10% chance of receiving 2,000 and a 90% chance of receiving the lower amount of 1,600. And this, under option B, it says that there's a 10% chance of receiving 3,850 and a 90% chance of receiving the lower amount of 100 kroner. If you divide these amounts here by 4, then you have these amounts in New Zealand dollars. So these are quite large payments to subjects. We did have some budgetary constraints, so we only give subjects, well, we give them a 10% chance of winning in each of these. So we select one of these 40 decisions here at random, and then we give them a 10% chance of winning, and then if they win, we play out the lottery and they receive the outcome at the end of the experiment. So on average, I think they won a bit over $50 in this task. And then on top of that, we gave them, just to show up for a 2-hour meeting, we also had a treatment on the fixed amount that we paid them to show up, and we paid them either 300 kroner or 500. So if you divide that by 4, you have it in dollars. So was that $75 or 125?
I'm not too familiar with anything other than the Holden-Lowry list scheme. This is certainly different, but asking like the same question, correct? So I presume that you're getting better information or something by doing it sequentially, one at a time, and using the pie charts. So with the Holden-Lowry, I guess the standard form might have noisy results because it's confusing the subjects, or so you found some differences then, so I'm guessing that
well, the thing is, if we just look at the risk aversion, so I should just say that the next decision, number 12, it would give a 20% chance of the high amount. The decision number 13 would give a 30% chance of the high amount, and so on, right? So we had 4 blocks of 10 decision tasks, And across those 4 blocks, we vary these stakes here. And then otherwise, we increase the probability. So there's this Holden-Lowry order to it. Now, if we just look at the risk aversion tasks alone and look at the average constant relative risk aversion number, then it's basically the same. There's not much difference. The reason we went to, I mean, we've used the Holden-Lowry design in the past, and the reason we went to this design here is that it's much easier to explain to subjects. We have these, last time we had 2 decision tasks, the discount rate and the risk aversion task. This time we had 4 decision tasks on top of these 3, the risk aversion, the discount rate, and the combined one. We also had a trust task at the very end. And that's a lot to do in 2 hours. So we had to find a way of explaining this quickly to subjects. We also run pilots before they actually come to these to the real tasks. So we run pilots where we pay out the amounts in candy. So it all takes time. So we were able to reduce this to 1 A4 page with instructions and an example on the right-hand side. So we had these laminated instructions on an A3 one sheet, and then on the left we had the instructions on the right, an example.
So
Time efficiency, yes, and it went quite fast, I would say. Yeah.
So what, in this one here, like in that, what you're seeing is sequentially, like 11 and 12 and 13 and 14, they'd be seeing the size of the blue pie pop up like that. But what they don't see is that, are they conceptually aware of that this is a group of 10 starting off at a 1 in 10 and it's going to move its way up?
Yes.
So they kind of, they're aware of that even though they don't actually see the, like in the multiple price list thing, you've got list 1 and list 2 kind of coming down like this. Where do you want to switch?
Yeah, yes, they were aware of that. We haven't tested for this whether there's more or less switching forwards and back in the Holden-Lowry multiple price list. You can see people switch forth and back between A and B as they move down the table, and we haven't seen, or we haven't checked whether this will increase or reduce that type of behavior. So we haven't tested for that.
Just watching people do the whole mile, right? Many times they don't actually fill it out sequentially. They go, something like that.
Yeah. So, yeah.
Because you could introduce into this design, you could introduce that interface that we had with the sports betting odds things, because then you see the simultaneous. So here's bookie 1, bookie 2, bookie 3. It's kind of geometric. It's not. It's graphical with this library type thing, but it's kind of all out there in front of you.
Yeah. I mean, we have been inspired. Well, we've been thinking about the slider issue also to introduce that at some stage, but this was really just to try to do this as simple as possible and for subjects to do these things as quickly as possible, really, or just to keep it within this time frame. We had up to 15 subjects per session. That's also a factor. And these are just ordinary people coming in, and sometimes they need help with just the most elementary stuff. All they had to do was just to click on buttons with the mouse, and for some of the older subjects that could be hard. So and in a few cases we simply just had to give up. So but that was, I think that happened in like 4 or 5 of the subjects. We had 413 subjects in total.
So in order to randomize the outcome, right, did you have a random number generator, or did you actually roll the die?
We rolled a die. Yeah, in the past we've used these bingo cages and so on, and then shown the number and all that stuff. To go through that process takes time and so on. It's easier to explain this thing about rolling a die and so on. Some people have seen a 10-sided die before, others haven't. So on.
I was curious if you had it all in the program, or if you actually physically.
No, we did. Oh, we did. We always do that physically. So I think personally I would be a bit suspicious if I heard about some electronic randomization device. So I want to see it physically. Since, I mean, this for the risk aversion task here, this was really just to control for the concavity of the utility function. So we don't really have many treatments in here. We have the risk aversion task before or after the discount rate tasks. We do provide a random order of these price sets that we provide to subjects, and then we have higher or low stakes. We also vary the principal in the discount rate task, and since we vary the principal in the discount rate task, we also want to see if there is increasing relative risk aversion or constant relative risk aversion, or perhaps even decreasing relative risk aversion. So that's why we introduce the high and low stakes also in the risk aversion task. The discount rate task is similar to the one, or to the risk aversion task, except that we don't provide lotteries now. These are just a certain amounts but paid out at different points in time. So this is decision number 1 out of 40, option A, option B, to be paid in 1 month, to be paid in 2 months. And then we show the amount. And then over here in one treatment that showed the annual interest rate, and that's 5% in this case here. So this amount here is 5% higher than this one, and then they choose between A and B. And then in some cases we provided this interest rate, in another treatment we didn't provide this interest rate here. And then we also varied the front-end delay here of 1 month, so sometimes we paid it out immediately. And then again we provided, or each subject was given 4 time horizons. In this case, the time horizon between the two amounts, the two amounts is 1 month, and they had 4 blocks of 10 decisions to make in the discount rate tasks, where they would have 4 different time horizons. So 40.
You have to worry about the fact that the subject would sort of wonder if you run out of money after the first month and there's nothing left.
No, well, it's a very good question. So it's about credibility of payments. Of course, that will have an immediate impact on discount rates, and then you would expect them to take the sooner option. What we did was we gave subjects, we had a guarantee or a statement we had from this time. This was done in the name of the business school in Copenhagen. And we had this guarantee that was written out in the name of the business school, and they could send this guarantee in a prepaid envelope to a private bank where we had set up a bank account for these payments. So what we did was we didn't want to have anything to do with the later payment, but we wanted the bank to take care of the transaction. And then they would get a copy. They would get the original of this transfer paper that we filled out. We would get a copy of it, and then they could take the original and put it in the prepaid envelope and then post it to the bank, and then they would pay out the money. So that's how we did it. We tried to make the process as credible as possible. We don't have post-dated checks, which is a great pity. I mean, that would have made life a lot easier, because you would just have filled out the check and then they could go to the bank, or they could just send it to the bank and then they would take care of it. So we had to try to make it credible, and also without making it costly, because sometimes the bank fees of filling out these forms can be quite substantial. I mean, very high. But last time I think we paid. It was a crazy amount we paid last time for the transfers. That's how we did it. We didn't really. We had a few comments about the credibility issue, and the interesting thing is that actually happens in some of the more remote regions of the country. So, and this time it happened down south near the German border, and I don't know exactly why that was, but that's where I began to get comments about this credibility issue. That was the only time I experienced it. But it's the interesting thing is that few papers in the literature, they actually talk about how they make these payments credible. So although it can have quite a large influence on the estimated discount rates.
So with a treatment for that, then the costing mechanism that you went through versus another set of experiments where you're just writing checks, posted checks.
Yeah, or just say that, well, we'll just transfer the money to you at that specific date. Yeah. Yeah, that would actually be a nice one. Yeah, yeah. We had the upper interest rate, or the highest interest rate that we provided was 50%. Again, one task was picked at random for payment, and then we gave them a 10% chance of receiving the money. We had the treatments we had was this thing about the front-end delay, no front-end delay, a principal of 1,500 or 3,000 kroner, information on the annual interest rate or no information, and then this idea of ascending or descending time horizons as they were presented to the subjects. Then we do a joint estimation of risk and time, of these risk and time preferences. So first we state the likelihood of choices over the lotteries, then over the discount rate tasks, and then we pool over all 413 subjects. We can also play around. In the benchmark, we just assume expected utility theory when we specify the choices on the risk. We can also use alternative specifications like rank-dependent utility, but we don't really find any difference there. So we just stick to UT in the estimations that I'm going to present. I just stick to UT. I'm also going to talk a little bit about mixture models, because it may be that people have more than one latent preference function. So this is just the idea that the behavior can be specified or represented by more than one preference function. So we do mixture models of exponential discounting functions and different hyperbolic and quasi-hyperbolic specifications. So we can try to estimate the fraction of observations that can be explained by either of those two theories.
Do you control for wealth?
No, that's a good question. No, we control for income. We have information about income, or at least income brackets. We can get, we have a questionnaire at the end of the experiment where we ask about some background characteristics. We tend to keep it short, and when we ask about income, we provide income brackets, and then they simply just mark the one that fits best to their situation. Wealth of course, it can have an influence on, or you would expect these preferences to vary across wealth levels. One thing that is nice about the Danish context is that we have personal ID numbers, and then we have an amazing database at Statistics Denmark that goes back to the early 70s when these personal ID numbers were introduced. And they just record anything that they can get their hands on people. They record that stuff, and everything is just collated at Statistics Denmark. And we can map the data here to the data at Statistics Denmark, so we can get all this information. For household wealth, they can split out about 50% of personal wealth. They can split out, or they have information on that on an individual basis. So they have details from private bank accounts. They also have from the stock market. They don't have from pension schemes. That's a good 35% chunk of the overall personal wealth. They're working on getting that information. So the only part that'll be left is only 15%, which is pretty much what people have in private firms and so on. So everything else can be also the housing stock can also be separated out. That's where that's like 40% of private wealth or something like that, and that could be separated out on a personal basis. Mm-hmm.
We're all totally envious about data availability here, but I
know that I've seen something. I think it was Swedish data where they had basically AFQT scores from military recruits, and everybody was required to be in the army, right?
Yeah, we would.
Get an IQ test. Is there anything similar?
Yeah, we have that.
So you can put IQ scores in here and
Yes.
the differences by IQ?
Yes.
Oh,
Yes. Yeah.
sweet.
See, the thing is, there are even some taxes that are still kept in place simply just because of statistical issues. There is a pension contribution. It's very, very small, but it's a fixed. It's a fixed cost that depends on how many hours you work, and it's nothing. I mean, but they just keep it in there for statistical purposes because it gives you an indication of working hours for people, and then you can relate that to tax databases, and then you can get an estimate of hourly wage rates, for instance. And that number is unique.
I know that the IQ data has been used looking at financial market behavior and seeing if people are trading too much and that sort of thing.
Yeah.
Can you determine the education and prior business experience exceptions?
Yes, that's also available. You can even link between generations and stuff like that.
You're describing a situation which to an Anglo-Saxon is a privacy nightmare.
Yes, I know. But we don't have, but we don't have cameras all over. Yeah.
So I think you already answered this, just to clarify. In the event that there is hyperdelicate discounting out there, but it's only a minority of the population who's like that, and most people aren't, you would pick that up in your mixture models. They could show you that, yes, we are finding evidence, but it's only a small minority.
Yeah, yes. And we can also condition the parameters in the mixture model on observable characteristics. We haven't done that so far, but that's also a possibility. Now the thing is, that becomes quite data intensive. So we would also, there's a limit to how much we can do, but we can also condition on personal characteristics. So since we have access to this database of Statistics Denmark, we wanted to reduce that questionnaire in the end because we're going to map it anyway. And so we will get the...
They're just looking at, do people lie on these kinds of surveys compared to the government data that they've already got, right?
Yeah, I see one thing we're interested in is knowing more about the selection process also into these experiments. One thing that we've noticed this time is, see, when we sent out the invitations in the name of the ministry, we had 40% of the subjects, they responded positively to the invitation. Once they're recruited, 95% of the subjects, they show up. It's amazing. I mean, it's the initial part that's the crucial one. And then this time when we sent it out in the name of the business school instead, that response rate dropped to 20%, or between 15 and 20%, depending on whether they got the 300 kroner or 500 kroner. So the fixed payment has an influence, right? Which is also what you would expect. I mean, what we've been looking at in one paper previously, we've been looking at this mix between fixed payments and variable payments, and whether that correlates with your risk preferences. And there is some tendency, or we see some tendency there. So in the past, we've used 500 kroner as the fixed premium, or just the fixed payment, and we tend to recruit subjects who are, well, the more risk-averse pool of subjects, really. So that indicates, well, so that there may be some effect of this mix between the fixed and the variable payments.
I have no idea what the kroner is worth. 500 kroner is what fraction of the GDP?
So 500 kroner, if you divide that by 4, then you get it in New Zealand dollars, so 125 New Zealand dollars. I can't remember what the average income in the Danish context is. It's a good night out, I would say. 500 kroner, you can, yeah, it's a good night out.
In your recruitment process, like the selection process, I didn't understand that. Seems quite interesting, but you mentioned that some of the people, because they're elderly, have difficulty either knowing the technology or punching the right keys. So you're getting quite a range of ages and health conditions and educational backgrounds and that sort of thing coming out in that. But with little idea of how the 60%.
Well, we know, I mean, we stratify the sample and then send out the invitations, and then we have a good deal of background information, so we can look at sample selection issues to a much greater extent than we could in the past, because well, not really. We can still get the same information in the past. So what we've done, let me put it differently. So far, when we the process is we first get a sample. We have a civil registration office, and we get a sample of 50,000 subjects from that office, and then we stratify it ourselves. And when we get that information, we get age, sex, and address. So those are the factors that we have used in the sample selection models in the past. We are also this time we are also running a panel experiment. We also did that last time. So there's also this issue of attrition later on, right? Last time we didn't map it to Information and Statistics Denmark, or we are in the process of, we've done it now because we want to look at this wealth issue and issues of asset integration and so forth. But we are going to do it this time for the sample selection issue. So we're going to build in more controls for sample selection this time than we did last time.
Do the subjects make up a stratified sample? Invitations are apparently.
It's yeah. Well, I mean, it's when we look at the when we look at the questions that we ask about income and education and so on, it's representative. Now, we did have some, or we have had some recruitment problems in the more remote areas. So geographically, we do see some effects on, when it comes to the geographic parameters in the selection model. We do see some effects. So it's harder to recruit in the southern areas compared to around the capital and so on. But otherwise, I mean, what we've seen so far, just from the questions we ask in the questionnaires, it seems to be representative of the population. But again, I mean, there might be some things that we haven't controlled for where there might be a sample selection effect. We don't see it for, I think this time, I think we see, or at least we suspect that there is an age effect this time. It seems like it was harder to recruit younger people this time than last time.
We might want to have some sample selection issues, so if you got, I'm imagining where we've got all the data on everybody, why not oversample deliberately criminals, multiple bankruptcies, anybody where you no, this is because people are irrational and they're hyperbolic.
Yes, that's the next step. That is to, I mean, one conclusion from this stuff here is that, well, we don't, it's just going too far to say that we find hyperbolic behavior all over the place. And that's what we've heard in the past from all these hyperbolic guys, right, in the literature. So this is not what we find. It might be the case for certain population groups. And now we need to identify which groups those are and where we actually find that type of behavior, at least in the Danish context. I can only base my arguments on the Danish context. But that's what we're going to do next. And one obvious focus group there will be addiction groups. Let me just skip over the statistical stuff really, and go directly to the results. So what we see is for the exponential discounting model, the average discount rate when we control for this concavity here of the utility function is 5.6%. So it is a bit lower than what we found in the past. We find no evidence for quasi-hyperbolic discounting or fixed cost discounting. Slight evidence for Weibull discounting, And there we see that the discount rate is 6.7% for 1 day, a time horizon of 1 day, 6% for a 2-week time horizon, 5.1% for 1 year. This is a bit low tech to move between the files in this way. Let me just briefly show you the results here. So this is the the exponential function here in the upper panel A here. So this is the delta parameter, this is the point estimate, the standard error, and then the p-value where this test is whether the discount rate is equal to 0 or not, and then the 95% confidence interval. So we see that it's 5.6%. This is the quasi-hyperbolic discounting function here, where the delta parameter is 5.7%, beta is 1.002 with this 95% confidence interval. If beta is equal to 1, then it's exponential discounting. And if it's less than 1, then we see hyperbolic discounting. And this is the test of beta, and with a p-value of 0.55. And then this is the fixed cost specification. The important one here is the b parameter here for the fixed cost. If that's equal to 0, then we see exponential discounting, and the 95% confidence interval here is between minus 0.061 and 0.029. And then we also have the Weibull specification, and the parameter there to focus on is this S parameter down here. If S was equal to 1, then it collapses to exponential discounting, and we see that the 95% confidence interval is between 0.773 and 1.324. So we don't see any indication really, or statistical, or we can reject the assumption of hyperbolic discounting for this function here. If we use these or if we make a prediction about the discount rate for these parameter values here in for the Weibull specification, then we get these discount rates that I just mentioned. So from 6.7% for 1 day down to 5.1% for 1 year, and you can hardly say, well, it's a very small fall in the discount rate. So, and we can also look at the mixture models. If we look at the mixture models and the exponential and quasi-hyperbolic specification, then there is a 28% weight for the exponential function and a 72% weight for the quasi-hyperbolic specification. However, the beta parameter in the quasi-hyperbolic specification is not statistically significant from 1. So what we are seeing here is we are seeing 2 exponential types of people. One with a low exponential discount rate and another type with a higher exponential discount rate. So we see 28% of the observations are for a discount rate of 15.3% and 3.3% for 72% of the observations. And then we can do the same for the exponential and Weibull distributions here. There's not much difference in the weight for the exponential guys. And again, we cannot reject the hypothesis that the S parameter in, in the Weibull specification is significantly different from 1. So it seems to be rather robust, at least across these specifications, or this Weibull, the distribution here, and the quasi-hyperbolic one, once they are combined with the exponential functions.
These aren't conditional on your demographic characteristics.
No. No.
So
No.
you have step results for that?
No, not yet. No, it could be that we see a tendency for hyperbolic behavior among certain groups. That's perfectly. That could be the case, and that's something that we're going to look into.
Well, I quite like this Weibull function idea that the sort of compression of time, and you think that could be easily age dependent.
Yeah.
Though I don't know exactly how, and I don't know what theory I would use, but that would be interesting to see if there is some age dependence in these kind of results.
Yeah, I also like that a lot. And it's remarkably easy to, I mean, it converges well. We don't really find any numerical problems with that specification either. So those are the main results. So this is just to illustrate what the Weibull one looks like for the mixture model. So it's not that dramatic really. So the question is, of course, why don't we find hyperbolic behavior? Since so much has been made out of this in the literature, and it seems to be this conventional wisdom that we should see it all over, more or less. If we look at the past literature and ignore, I mean, most of the literature uses use hypothetical tasks. We also see that many of some of the papers are based on experiments that are not incentive compatible, or where the subjects don't have an incentive to reveal their true preferences. But once we begin to ignore those papers, then we're left with few papers that use real monetary incentives. All of those studies are with students. And another, what else we see is that the elicitation mechanisms are based on these matching tasks and open-ended choices. So what I mean by a matching task is that they are told, that could be, for instance, we have a principal of 3,000 kroner. So the question would be, what makes you indifferent between receiving 3,000 kroner now and some amount X in 1 month? And then you could use the BDM, the Becker-de-Groot-Marchak mechanism in this case, to elicit the preferences. So they would state some amount, let's say that they're indifferent, that they state 4,000, and then a random number is, let's say they just pick that the highest amount that they can pick is 6,000, for instance. So they use interest rates up to 100% over this 1 month horizon. Then they would pick a random number between 3,000 and 6,000. If that number is less than 4,000, you get the 3,000 now. If that number is higher than 4,000, you get the random number later. So that's a typical elicitation method in the literature. And this combination here of experiments with students and elicitation tasks of this type here, that or at least we see hyperbolic behavior with these studies. So what we did in the next stage is that we conducted some lab experiments with students. We didn't change our elicitation mechanisms. I mean, we kept that the same, the treatments the same, and so on. And again, we find, well, this time the exponential discount rate, it increases a bit to 7.6%. We don't find any quasi-hyperbolic behavior, and we don't find any hyperbolic behavior with any of the other specifications. However, for the Weibull specification, when we make a prediction there, we do find that the discount rates are somewhat higher for the shorter time horizons. So 19% for 1 week, and it goes down to 7.3% for 3 months. So there's a tendency for more hyperbolic behavior among these students compared to the overall sample of the population that we have. I still have a little bit of time, so let me just briefly talk about this correlation aversion idea. And that is, we want to move away. So far when we do these estimations, we assume this additively separable utility function here. And we want to test whether that's a reasonable assumption or not. So again, as I said early on, is that it forces this inverse link between the intertemporal elasticity of substitution and relative risk aversion. We add a third task to try to elicit this sigma parameter in the specification over here. So just to, yeah.
So all the models of discounting treat losses and gains symmetrically.
That's a good question. In the experiments with real monetary incentives, those are all based on in the gain domain. I don't think any of those are in the loss domain. I would have to check that. I'm pretty convinced that those are in the gain domain. There are a few of the hypothetical ones that look at losses. And I think the conclusions there, are more or less inconclusive of hyperbolic discounting. But that is certainly an area that is very interesting to, I think maybe there's one experiment. See, we've only been focusing on the gain domain here. There might be, yeah. But that's a very good question. And that's, in my mind, that's open for research. I mean, I haven't, again, when you look at the number of studies that have been done with real incentives, it's actually surprising how few studies there are out there. And the loss area is completely open in this field here. That would be very nice. That would be very, very nice. And then combine it with loss aversion and stuff like that. That would be very, very nice. So let's just, let me just to put some notation on the idea here. So the arguments in the utility function, you have large x here is money in some sooner time period t, y is income in a later period t plus tau, and then you can have some elements, big and small x in x here, where big X is greater than small x, and the same thing for y here. Let's just assume that that the discount rate is 0 for the moment, and then look at two lotteries here. So lottery alpha is a 50-50 mixture where you receive X is where you receive a smaller amount now, a larger amount later, or a larger amount now and a smaller amount later. And down here you receive the two bad outcomes now and the two good outcomes later. Now if the discount rate is 0, then the expected value of these two lotteries is the same. But if you're correlation averse, then you prefer this lottery up here to this lottery down here. So here you receive two bad outcomes now or two good outcomes later. Here you receive a mix of good and bad outcomes now and same thing later on. And we do this, but just where we have this, we present these lotteries to subjects where those amounts are paid out at different points in time. And this is where this combination between the risk aversion tasks and the discount rate tasks comes in. So let me just show you the basic task that we gave to subjects. So this is similar to the ones that we gave them for the risk aversion task. This is decision 1 out of 40. We present these pie charts in the same way as the risk aversion tasks. And then this says here that if the die shows 1, so there's a 10% probability of receiving 2,000 today and 75 in 5 months. That's for this part here. So a high and a low one, and a 90% chance of receiving a low amount today and a high amount later on. Over here there is a 10% chance of receiving 2 high amounts here now and a 90% chance of receiving 2 low amounts later on. And then we increase we just increase the blue area here as you move through the tasks, right? Then in the next task, this increases to 20% for both options and so on. And this will enable us to estimate this sigma parameter here. So that is the basic idea. The estimation technique is exactly the same as before. We have the risk aversion task. Well, we have a likelihood specification for the risk aversion task, or for this instantaneous utility function. We have a likelihood specification for the discount rate part, and a likelihood specification for the correlation aversion part. And then we add all these three components to a grand likelihood and estimate the parameters. And what we find is, we find here that this sigma parameter here is 0.374 with a 95% confidence interval between 0.247 and 0.5. So we do find that people are correlation averse. And we also, then we can begin to, what we did also was, I mean, we've just played, this is really work in progress. I'm still working on these specific, I mean, the thing is, so far we have just used simple specifications like a constant relative risk aversion function for this part here, and also this is also a CI function for all that is in these brackets here. You can also play with more flexible functional forms like expo power and so on, and we're looking at that at the moment. I would be surprised though if there's much variation in this one. You never know, but we're going to check that. We do find a little bit of a few differences when it comes to observable characteristics. So we did this for when we look at where we control for demographics, and we do find a sex effect here. So women seems to be, well, oh sorry, this is for the R parameter. We do find that women, they seem to be a little bit more risk averse than men, and for sigma we also find that women tend to be more correlation averse than men. So we do find this a sex effect. This is when we look at marginal effects. We can also look at total effects, and there we find the same. This is when we just control for female alone without including all the other covariates. We control for the various treatments for the different parameters here. But if we look at total effects of sex, then we see it's statistically significant for the R parameter and the sigma parameter. So we do find some variation across men and women. The main story here is this hyperbolic story, of course, and that we don't find any hyperbolic behavior when we look at it overall for the population. The next step is now to try to identify if there are certain groups out there who exhibit this behavior. And I mean, an obvious direction to go is to look at people with some addiction of some sort, or other types of other focus groups. It could be, I mean, we always ask questions about smoking, and we have we also find we just got a paper out in Journal of Health Economics where we look at this connection between discount rates and smoking, and we find that we do find an association between smoking and discount rates for men, but not for women. So men with a higher discount rate, we find a positive correlation. So smokers, they also have higher discount rates among men than non-smokers, but not among women.
But not higher.
Well, we would need data from this experiment ourselves. We can't test for the quasi-hyperbolic specification with the old data we have, and we don't really have. We don't have this variation in the principle, So we can't test for those specifications. So I would say that the data set is not reliable enough to be able to test for those things. But that is certainly something we're going to do with this one here.
I just had a question because I think maybe I just missed something. When you sort of switch to the end of the discussion of correlation aversion and you're finding evidence of it, does that shed any light back on the fact that apparently you found no hyperbolic discounting? That maybe there is hyperbolic discounting, it's just that there was this wrong implicit assumption that there's no correlation?
Yeah, yes, that's a good question. We want to look closer at that. So what we can do is, I mean, we can certainly look at other specifications than the exponential one once we also control for correlation aversion. And that is something that we want to look at next. So what we can do is, I mean, we can maintain what's outside the bracket here and control for this sigma parameter here, and then have more flexible specifications for the delta one here. But I would be surprised if we see much of an effect there, really, because this delta parameter has very small influence on the estimation of sigma here. I wouldn't expect that there would be much of a correlation between those two, but we need to look closer into this. We've just started to look at these things here, but that's the next one of the next steps. And then there's the panel stuff on top. So we're returning to 200 out of these 413 subjects. We returned to 100 of these guys 6 months after the first experiments. We did this in October last year. We returned to 100 in April, and we are returning to another 100 subjects in October when I return from here. And the idea there is to look at whether the discounting function is stable over time or not. And we can make more direct tests of this discounting behavior, whether it's consistent or inconsistent. So that's where we stand at the moment. So lots of stuff to do still, and lots of data to play with.
It was a great seminar. Thank you for that.
Thank you.